Hi everyone, I am Bhagyalakshmi from ECA final year. Today we are going to present our project titled Smart Saline Monitoring System using load cell and GSM module. This project focuses on improving patient safety by automating the monitoring of saline levels. It has been developed by our team under the guidance of Ms. Prabhavati, Assistant Professor of Department of ECE. Abstract. Our project is designed to automate the process of saline monitoring in hospitals. Traditionally, nurses manually check saline levels, which is time consuming and prone to human error. In our system, we use a load cell sensor to continuously measure the weight of the saline bottle. The Arduino processes the data and determine the fluid level. If the saline level drops below critical point, alerts are generated using buzzer and GSM module. This ensures timely response and reduces risks associated with the empty saline bottles. Problem statement. In current hospital, the saline monitoring is done manually by nurses. Due to heavy workload and multiple patients, continuous monitoring becomes difficult. Sometimes the saline bottle may become empty without being noticed. This can lead to serious medical issues like blood backflow or air embolism. Hence, there is a need for an automated system that can monitor saline level continuously and provide alerts. Introduction. IV saline plays a vital role in patient treatment, especially in critical care. Monitoring its level is essential to avoid complications. Manually monitoring methods are not always reliable due to human limitations. Delays in replacing empty bottles can cause severe health risks. Therefore, implementing an automated and real time monitoring system can greatly improve healthcare efficiency and patient safety. System overview. Our system continuously monitors the saline bottle using load cell sensor. The sensor measures the weight and sends the data to Arduino microcontroller. The Arduino microcontroller processes the data and calculate the remaining saline level. If it is the level falls below the threshold levels, then it triggers the alert. The GSM module sends an SMS or call notification to the medical staff instantly. This system reduces dependency on manual checks and ensure quick responses. Objective. The main objective of our project is to design an automated saline monitoring system. It aims to continuously track the saline level without human intervention. Another objective is to provide real-time alerts to medical staff. It also focuses on reducing workload and improving efficiency in hospitals. Additionally, the system is designed to be low cost and easy to implement. Proposed system. In our proposed system, the load cell is used to measure the weight of the saline bottle. But the load sensor can give only analog data, but our controller cannot be accessed with the analog data. So here we use HX7 level load cell amplifier, which is used to convert the analog data into digital data. And the load sensor send the input to the HX7 level load cell amplifier. Then it filtered and processed the analog data into digital data. Then it will be carried to the microcontroller. Then the microcontroller getting processed with compare the input values with the threshold values. If it is the threshold value was greater than the input value, it will be generate alert, and there is threshold is lesser than the input, means it going continuous monitoring. Literature review. In the literature review, we are analyzed the existing saline monitoring system. Many systems rely on manually observation or simple sensors like float sensor. These methods lack accuracy and real-time communication features. Some advanced systems exist but are costly and complex. Our proposed system overcome these limitations by using load cell for accuracy and GSM for instant communication. Function flow. The system begins by sensing the weight of the saline bottle. The data sent to the Arduino through the HX711 module. The Arduino processes the data and calculate the saline level. If it is the level is low, an alert is generated. Finally, the GSM module sends a notification to the medical staff. Block diagram. The block diagram represents the overall structure of the system. The load cell acts as the input sensor. The HX711 module amplifies and converts the signal. Arduino acts as the main processing unit. The GSM module is used for communication. The output includes alerts such as SMS, call, or buzzer indication. Components. In this project, we use hardware components and as well as software components. Hardware components are load cell, HX711 amplifier, GSM module, and Arduino UNO board. And in software, we use Arduino IDE for coding and system control. Working principle. The working principle is based on the weight measurement. The load cell detects the weight of the saline bottle continuously. This analog signal is converted into digital from using HX711 load cell amplifier. Arduino processes the data and calculates the remaining fluid value. The value falls below means then the alert is triggered. GSM module getting triggered to send the SMS or make a call to notify the medical staff. Methodology. Our methodology involves several steps. First, data is collected from the load cell. Then the signal is processed and filtered using HX711. Next, the Arduino UNO compares the data with the threshold value. If the condition is met, an alert is generated. Finally, the GSM module sends a notification to the user. Project process. This is our Arduino UNO board program. First, we call the load cell library file and GSM module library file. First, we call the pins of HX711 pins. From the DOut of the HX711, we connect to the third pin of the Arduino UNO and clock to second pin. Next, GSM pins. Software serial pins, we call the 7 and 8 pin of the UNO board for receiver and transmitter. For voice module pin, we use the 9th pin of the UNO board. Calibration factor, the total weight of the saline bottle. Threshold grams for the threshold grams of the saline bottle. Float level is 150 grams, and float critical level we set the 50 grams. Then we call the details of patient with the module pin and bit number, calling SMS sent likewise. Function to make the call. Make the call using GSM module. First we call and one command. The command is called the ATD. This command is used for make a call, and then the voice module getting on and with a delay of 3 seconds. Then it will be play the voice for the corresponding patient getting low level saline level. Then after the end of voice, the ATH command will be help to hang up the call. This function will be loop for the continuous monitoring. In threshold monitoring, we divided the three types of levels. First, medium level, second, low level, and critical level. In medium level, if the weight of saline bottle 75% means it will generally generate a SMS only for the corresponding medical staff. Saline level is getting medium in bed number. Whatever it is bed number, it will be produce. Level low level means it will be more than less than 50 percentage means the alert message will be provided. In critical level, it will be make a call plus voice alert and as also SMS for the medical staff. Result accurate saline level detection, which is accurate time accurate weight of the saline level will be provided. It accurately measured the saline levels and detected low level efficiently. Alerts were sent promptly without delay. The system reduces the need for continuous manually monitoring. Overall, the performance was reliable and efficient. Advantage: the system offers several advantages. It prevents seriously medical risks. It reduces the workload of nurses. The system is cost effective and easy to install. It also improves overall patient safety. Application: the system can be widely used in hospitals and also clinics, especially useful in ICUs, used in healthcare centers also, home healthcare also, and integrated into small medical devices. Future scope: in future this can be enhanced IoT technology, mobile application, remote monitoring. Then integration with the hospital management systems is also possible. AI can be used to predict the saline level. Thank you.